Welcome in my channel Digital World. In this video we learn how to draw Cmos layout of inverter with software that is Microwind. Now just click on File, select New, then again click on File, select Foundry, browse Foundry first, that is Cmos 012.rule file. Select it, click on Open. Now click here on Zoom in and click here in Windows. Next one is we have to draw layout of Cmos inverter. This is palette. Click here on MOS generator. This is width of MOS. This is length of MOS. Just click on MOS and select PMOS. So this is the symbol of PMOS. It consists of three terminals: gate, drain and source. Click here on generate device and click here on Windows. Now click here on zoom out. So this is our PMOS. It consists of three terminals. This is source, gate and drain, and this green boundary indicates NVL. Now again click here on MOS generator and select NMOS. Width and length remain same and click on generate device. Place this NMOS here, right? So there are two MOSFETs are there, PMOS and NMOS. Now select move and stretch and just select this NMOS. Align this NMOS with PMOS. Again align it properly, zoom it and check it. The alignment will be proper. Yes. So in case of MOSFET, the first thing that we have to connect gate of PMOS with gate of NMOS. So go to the palette and select polysilicon. So this is polysilicon, red color. Select polysilicon and just connect polysilicon of PMOS and NMOS. Width of wire remains constant and try to overlap polysilicon. So both polysilicons are connected together. Similarly, select metal 1 and connect drain of PMOS and drain of NMOS. Width remains constant. Now click here on VDD supply and connect VDD to NVL. Same VDD you should connect to source of PMOS. So PMOS and NVL both are at same potential. Then select here VSS or ground and connect to source of NMOS. So this is connected to source. Now we have to give inputs. So select clock and put clock on polysilicon. Rename this clock as input A of Cmos. This is rise time, fall time. This is clock. If you want to apply DC voltage, then we can apply DC voltage. There are multiple options are there: pulse, sine wave, variable we can set once and here we are considering clock. So click here on clock. This is high time, this is low time. Assign clock. So this is our A. Now here in the palette there is one output, that is visible node. So select visible node and here place on metal, that will be output. So rename this as OP and select variable. Then click on assign. So output is visible over here, right? So this is our layout of, this is PMOS, this is NMOS. Now to check errors, click here on analysis, design rule check. So here it shows that no design error or no errors in your design. Now we have to simulate this. Click here run simulation right? And this is our simulation. So we can observe here, this is A. When A is 0, output is equal to 1. When A is 1, output is equal to 0. If you want to change time scale, then you can select 2 nanosecond and select on reset. So you can observe here, green color indicates input, red color indicates output. This is the simulation of inverter, and see, this is the power dissipation of device. So P is equal to 2.69 microwatt. This is our power. Now if you want to use load, capacitive load, then we can connect here. You can select show palette. This is our capacitor. So select capacitor and connect capacitor to output. Change the value of capacitor. We can put here is 0.001 picofarad, and then click here on OK. So with capacitor, again we can check, go to the analysis, design rule check, no errors in the design, then click on run simulation. So this is the simulation of same inverter with respect to capacitive load, and here the power dissipation we should check. This is P is equal to 5.934 microwatt. In this way we can check the output of inverter. So there are multiple graphs we can check here. First graph is voltage versus time, second one is voltage versus current, third one is voltage versus voltage, frequency versus time, and last one is eye diagram. In this way, with respect to microwave tool, we can design layout of our circuits and we can check the output. Thank you.